Welcome back to another RC Worst video. Chris here, and today we're going to be walking you through how to properly wire an Orenco A1 control panel. We're also going to go through the functionality and the different configurations that are available with these control panels. So stay tuned, and it's about to get fun. Okay, so a quick overview of the A1 panels. They are a relatively basic panel that are going to control a single pump, and they're also going to have some alarm functionality. So it's a good solution if you're looking for something economical. But enough said on that. We're not going to go too into detail on the features of this panel. This video is more to teach you how to properly install it once you've made the decision to purchase it. So with these panels, with the standard A panel, you basically have two wiring configurations that are standardized for the operation of the panel. And I've taken the Splice Box wiring diagram and listed it over here so that as we go through the instructions of where to land the wires, we can correlate those with the splice box or the incoming wire feed that's going to be popping up through the bottom here. Something else that you'll find inside of these control panels is the float arrangement diagram. So this float arrangement diagram, it shows two different configurations, one with 2 floats and one with 3 floats, and we'll also link these documents in the description below so that you can follow along if you wanted to have those open or print them out on your own. All of these documents and more can also be found on rcworst.com. Just search for the panel that you're working on and you can find these. At any rate, the important thing to remember about the float arrangement diagram is it gives you crucial information about the float selection. If you don't opt for the default Orenco float tree and you're going to go out and purchase your own floats, you can use this float arrangement diagram, specifically over here where it talks about the float types, to determine what you need. So they break it down into normally open, no differential range, and a signal float or a pump float. So they go through all of that information, a wide angle float and so forth. So that's a nice piece of information if you needed to, let's say you bought a 2 float tree and you wanted to go with a 3 float configuration, run down to the hardware store or order from us a 3rd float, and you would be able to figure out which float you need. So enough said on that. We're going to be talking about this and going back to this just a little bit here in a minute. So back to the Splice Box configurations, and the reason that the Splice Box configurations are important is because the way that you configure your Splice Box, and we have both of those here, is critical to how you're actually going to bring the wires in and land them on the terminals at, below there. So we've got 2 standard options. You've got the just standard pump operation, which you've got your 3, let me grab this, your 3-cord grip splice box, and this of course is typically mounted inside the riser for your tank, and then this portion is inside the tank, and then the conduit goes out from there through the tank wall or the riser wall, however you've got it configured. So the first and most common configuration utilizes the 3-cord splice box, and you've got 1 cord for your high-level alarm, 1 cord for your pump on-off float, and then you've got 1 cord for your pump. So those cords are the cords that come off your float tree. You would just run those up and into that splice box, and then hand tighten those to get a good seal. And then also the same for the pump. So it's pretty straightforward, but where it gets interesting is once you get the float and everything inside of here, you're going to make those connections with the included waterproof wire nuts, and you're going to be hooking into, in most cases, THHN wire, which you're going to be running through your conduit back to your control panel. So with that THHN wire, you've got a lot of different choices for colors and so forth, and it is recommended that you run a separate color for each line so it's easy for you to identify, and it may be beneficial to kind of create a key and hand write inside of your panel what each color or wire goes to. But not every situation is that really reasonable, or maybe you've got 1,000 foot of black wire and you just want to use what you've got, and that's no big deal. So we're going to go through this here. This is available in color, but I printed it out in black and white specifically because we're not following the recommended color coding. We're just trying to also showcase that you can do it a number of different ways to get the job done. So the secondary optional, I guess, splice box wiring diagram is this one here, and this one offers the additional cord grip. So we would have the 4 cord grip splice box, and that includes redundant off functionality. So if you needed, or if you had a requirement in your area to have a redundant off, you may be interested in going with that configuration. And the nice thing about that is you're only adding a float, and you're not having to run any additional lines out to the splice box to get it done. So it's really not increasing the cost, but it is increasing the level of protection on the pump by ensuring that it's going to shut off when it's supposed to. Because one thing that can happen if you don't have a redundant off is your pump float can get stuck in the on position, whether it gets hung up in the tank or it gets waterlogged, and then the pump can continue to run. So a redundant off is a very useful thing for protecting the pump. Okay, so we're going to kick things off with the incoming power. So when it comes to incoming power, this is just some standard wiring that is used indoors most often. When it comes to these panels specifically, you've got a pump breaker and you've got a control breaker. So the thing to keep in mind is it is possible to simply bring one circuit or one power source into this panel and have it operate just fine, but there are kind of some pros and cons to that. Alternatively, it is possible to bring 2 power sources into this panel, and the benefit to doing it that way is you can have your pump on a dedicated circuit, and then you can have your controls on a dedicated circuit. The useful thing about that is if there's something, for instance, that trips the breaker, if your pump has a short in it or something along those lines and it trips the breaker, then if you're running on a single circuit, then you may not have an alarm functionality, so it could be detrimental. So the pump's not working, your system's getting backed up, your tank's getting full, but you don't have any alarms, so you don't really know what's happening until maybe some property damage or something starts to occur. So an added layer of security to the system and an added layer of reliability would be to have 2 circuits coming into the panel so that you could then have those 2 things be independent and more reliable overall. So hopefully that makes sense to you. We're just going to show a single circuit coming in and show you how you'd wire that up, because that's probably the more, I guess, complicated one of the 2, because if you're bringing 2 circuits in, then you're simply just going to hook it up the same way but without using these little pigtails that we've got. So let's get started on that. Oh, and before I begin, I also wanted to discuss one thing. So where we're entering the panel with our incoming power and going out to our splice box, normally you would want to have some sort of a seal off or connector or something of that nature, but since the regulations and rules on what is approved in these types of situations varies quite a lot state to state, we're not going to show that because I don't want anyone to mimic that. I would rather have someone with electrical knowledge that knows the code doing the proper box connection. So we're going to completely ignore that. We're just going to run the wires straight in the bottom of the box, but just keep in mind that's not how you want to do it. This video is more just to show the functionality of the panel, the wiring, and so forth. So just getting that out of the way, let's get started. Okay, so as I mentioned, we're just going to be doing a single circuit here. So for this configuration, you'll need 2 of these pigtails for the hot side and 2 of these pigtails for the neutral side, because if you haven't picked up on it, we're doing a 120 volt or A1 panel today. So let's just get these wired up, and the reason being is you don't ever want to land 2 wires on one terminal, so we're going to use some wire nuts and pigtail these out so that we can land it in multiple spots. So now we've got that one set up, and we're going to set up the other 2. So we'll loosen those up. And the first thing we're going to do is land our hots here. Sorry if my head's getting in the way. I got to see too, you know. Alright, so step 1's complete. I've landed our L1s on the pump and control breaker. Now I'll hook up the other ones. Now with the neutrals, we're going to be going to the terminal strip. We've got an N and an N1, so we're going to land those right there. So you might notice we switched to the red wire nuts. The yellows are just a bit tight for this type of application. So now you can see, and I've kind of pushed these wire nuts out of the way so you can see where the wiring is going. We've got the N1 and N landed here. We've got our L1 and L1 landed here. And then we took our ground and wrapped it back up and around and landed it on the ground point back over there. So that's all we need to know for incoming power. Now that you've seen that, I'll just kind of shove those out of the way, and we'll focus on the outgoing side of things, hooking up the pump, the floats, and all the good stuff there. All right, so we're going to go ahead and start by hooking our pump up. And on these A1 panels, it's easy to remember that 5 is going to be your neutral. So we'll go ahead and hook that up first and just kind of work our way my direction. And then we've got our hot, or L1 for the pump. That goes into 4 here. So just to refer back to the diagram here, we've got green for ground, terminal 5 neutral, you can see that one's white, and then for the other, which goes to 4, this kind of is a common here inside the splice box for the pump on off float, and that's what actually powers the float so that it can engage the pump when it needs to turn on. So long story short, number 4 goes right here. Now on the other end of number 4 in your splice box, this is how you would have it configured. You'd have your pump cord coming in and going into that waterproof wire nut. You'd have this wire right here, which is represented here, going into there, and then your white on your float going into there. So hopefully that's clear for everybody. And then last but not least, of course, we've got to throw the ground in here. All right, so easy as that. We've got the pump hooked up to 5 and 4, and we've got the ground hooked up. So we're going to hook up our float next. We've already got 4 hooked up, which that splice was made inside of the splice box. So now we just need to hook 3 up from the float. So if you decided that you wanted to run multiple different colors and know what cord it is, then great, it's going to be easy for you. Otherwise, figure out which one is the float cord, and that's going to go right here into 3. And we're just using red for this one just because we can. Break up the difference of colors. All right, so we've got that tightened down. Now make sure when you're doing these, you go through individually and tug on them to make sure that they're tight, because that's one of the number 1 reasons to get a service call and actually have a technician come out to your house is bad wiring connections. And if you can't figure out what's going on, then check your connections. That's always the first thing to do. All right, so now we're moving on. We're going to get our high-level alarm hooked up, and that's going to take up terminal number 1 and 2. Now, one thing to note here is it really doesn't matter the black or the white. It doesn't make any difference whatsoever. So just hook those 2 wires up for that float into 1 and 2. All right, so we're going to just do it the way that the factory's got it shown in the diagram, because I find the better you follow instructions, the easier it is to figure out what you did, the next time you're working on this thing. So if all your colors and everything match up to what they say, then it's a whole lot easier when you call us up and say, hey, I got a problem. All right, so we've got that one landed. We'll give it a quick tug. That looks good. And we'll run the last one here for the float. All right, and that's it. We've got that thing wired up and ready to go. So that was super simple and not much of a challenge at all. All right, so that wasn't too difficult getting that wired up. I just want to remind you, pay close attention to the splice box wiring diagram, because the actual cords on the floats and the pump cord don't directly correlate with what goes on in the panel. The splice connection beforehand is what makes everything work properly. And another thing to talk about with the floats, since we've got them sitting right here, in a panel wired for this configuration, you have this float here, which is your alarm float, high water float, and then this float here, which is your pump control float. Now, these are just simply close together, 1, because it's easier to show you, and 2, because that's how they're shipped. You use these set screws here and a screwdriver to move those up and down. So you loosen it up, set it to the height you want it, tighten it back up. And I also recommend offsetting them, so you would have, here I'll just loosen this one and show you kind of what I mean by offsetting them. So I'd also recommend you'd have them offset so that they're each traveling in different directions. Another thing that you can adjust is the length of the tether. In the case of this pump switch, you may want to increase the cycle beyond just this roughly 3.5-inch range. You know, if you increase the length of that cord down, you're going to be able to have a lot more swing, a lot more travel, and it's going to pump more. So that's how you're able to control, in a basic scenario, control how much volume you're pumping. And usually you base that on kind of how much of the tank you're trying to eat away with each cycle. So with that said, on the float switches, if your pump's not kicking on or your pump's not keeping up, then that's when this high water float would come up, and it's going to sound the alarm inside the panel. That's what this little relay does, is it creates a holding circuit that even if this float were to go back down, the alarm would still sound, notifying you that you had an issue until you came out here and cleared the issue by pushing the alarm to silence button. It's kind of a useful feature to be able to know that you've got something going wrong with your system, because usually if you're hitting the alarm, it's reason to look into things and just make sure that everything is working the way that it should go. Other than that, with the single float configuration, floats up, pumps on, floats down, pumps off. Super simple panel, super simple operation, not a whole lot of parts, easy to wire. So that's all we've got for you today. Thanks for joining us, and don't forget to like and subscribe. New videos every Tuesdays and Fridays, and we'll see you next time.